Hello, dear students. Welcome to my class of mathematics, the chapter 1, class 11 sets. In the previous videos, I have discussed about the basic concepts of the sets, types of the sets, different types of the sets, etc. Now, in this video, I will teach you about the operations on sets and what are the properties of the set operations. So how operations on set can be performed and what type of operations can be performed on the sets. Like if there are the two sets, set A and set B, then how many operations can be performed? Operations on the set. So there are basically 4 or 5 operations are performed on the sets. Set union, set intersection, set difference, set complement, set Cartesian product. These are the basic operations on set which are to be always to be performed. Let's discuss one by one. What are the set union, what are the set intersection, what are the set difference, complement of the set, and Cartesian product. Yesterday, in the types form of the sets like roster form and Venn diagram, I have told about the Venn diagram. What are the Venn diagram? Venn diagram are nothing but these are the that we show these in the circles. These are the Venn diagrams. Before going to operations on the set, let's discuss about the Venn diagram. So Venn diagrams are graphically represented in a circle, and in that circle, the elements of a set are to be put. And based on the operations of the set, we adjust the Venn diagram. Like if that is the union, then the common elements are common element, then intersection, there are others. I will discuss all of the operations, set operations in detail in later this video. So Venn diagram is represented with the help of the circle. So now come to the operations on the set. First operation is the set operations. Set operation, that is the set union. So in the set union, if there are two sets, that set denoted by A and another set is denoted by B, then union is represented with the symbol U, A union B. So set union, union of sets A and B is states that set of element A and B, or the both A and B. If there is a one set is A, another set is B, then A union B is such that X, the element of A, X, the element belongs to B, A, or X elements belongs to B. It means the all elements which belongs to A or B, or the combination of the elements A or B, but one condition is that the resultant union must be distinct. The resultant union must be distinct. In the union operations, only common elements are to be taken, or the common element occurs only once, and rest elements are occurs. Like, let's think it as an example. As set A is 10, 11, 12, and 13. And B is 13, 14, and 15. Then what A union B? A union B states that all elements of A, it means 10, 11, 12, 13, and elements in B, but if an element occurs more than once, then only one time that element is to be written only one time. 10, 11, 12, 13, 14, and 15. This is the A union B. It means common element here. Common, what is the common element? Common element is the 13 in both A, set A and set B. So that occurs only once. 10, 11, 12, 13, 14, 15. That is the result of union of sets A and B. With the help of the diagram, we can show it like this. The A set, B set, and common elements occurs only once. With the help of the diagram, we can show it as like this. I hope you understand set union. Again, I'm repeating. The set union operation states that the resultant elements are from the both sets A and B, but the repeating element occurs only once. Now, second operation is the set intersection. If there are two sets, A and A, B, then the symbol of the intersection is A intersection B. The intersection of sets A and B is the set of elements which are in both A and B. It means set union is an OR operation, but set intersection is AND operation. OR condition means either that is in A or that is in B, but must be distinct. AND operation states that the value must in B. Like in the simple language, if I say that we will go to picnic, if the weather would be clear or Neha will be with us. If one of the condition is true, then that is the union. But in AND operation, both condition must be true. That all students will come to the school if school will be open and if the day would be sunny. It means both conditions must be followed. AND operation, A intersection B, if elements A and B elements, then it states that X is such that X belongs to A and X belongs to B. Both conditions must be true. Like similar, if set A has element 11, 12, 13, and set B has element 13, 14, 15. Then what is the common element? Common element A intersection B is equal to 13, because only one element occurs in both, that is the 13. Okay. So that is the set intersection and operation. Now, what is the set difference? The difference of the sets A and B is the set of elements which belong to A but not to B. Or B minus A means which belong to B but not in A. Set difference states that if there are two sets A and another set is B, set difference A minus B states that the element of A, only elements of A occur, but that must not be in B. Like set A has elements 10, 11, 12, and 13. And B has element 13, 14, 15. Then A minus B is equal to 10, 11, 12. Because the difference of the sets in this order, the set of elements which belong to A but not B. Here 13 belongs to B. Elements 14, 15 will not occur in the result, and 13 will not occur because 13 belongs to B. A minus B is equal to 10, 11, 12. Or similarly, B minus A, in this case, B minus A, here 13 occurs in A, so 13 will not come, only 14 and 15 will be the result. That is the set difference. Set difference means that A minus B, the value of A belongs to A but not to B. Similarly, B minus A, value of B, and it doesn't belongs to A. Now next, complement of set. Complement of set. Complement of set is A and it is represented as A. It is a set of elements which are not in set A. Set of elements which are not in set A all other elements which are not in set A. If A is the set such that X is such that X doesn't belong to A. The element which doesn't belong to A, it is the reverse of A, like universal set, or we can show that A complement is U minus A. U is the universal set. U is the universal set that contains all objects. So if A belongs to set of odd integers, like if A is such that elements of A such that X belongs to set of odd integers. What the A complement? A complement is the elements which doesn't belong to odd integers, which doesn't belong to odd integers. A complement, it is the reverse of the set u minus a. Next is the Cartesian product or the cross product. Cartesian product of n number of sets a1, a2, a3, a4, or it can be denoted a1, a2 till an. If all possible ordered pairs from both the sets A that belongs to A, that belongs to B. Like if we say that, let's consider set A is equal to AB and set B is equal to 1, 2. Then Cartesian product of A into B is such that A element 1, A second element, B first element, B second element. This is the Cartesian product. And if you are you have to do the B and A, then 1, this 1 and A is to be multiplied, then 2 to B, 2 to A, 1 to B, 2 to 1 to A, 2 to B. So 1A, 1B, 2A, 2B. This is the Cartesian product. Cartesian product is the all possible order pairs where element belongs to A1, A2, AN. This is all about the operations, set operations on sets. Let's repeat once again. The set operation includes set union, set intersection, set difference, complement of set, and Cartesian product. Union of sets A and B is the set of elements that are in A, in B, or in both. It is the OR operation. Set intersection, it is the AND operation. Either the element in A and B, both must be there. Element, if common elements are to be calculated in intersection. Then in the set difference, it is A minus B, means all elements of A which doesn't occur in B, A minus B. Complement, it is the reverse of the universal. And then is the Cartesian product, it is the all possible ordered pairs of elements belongs to set A, set B. Next, come to the properties of the set operations. As we have studied previously in previous class also, that there are some associative or commutative properties, for the addition. For addition, if A plus B is equal to B plus A, it means addition is commutative in nature, as well as addition is also associative in nature. Similarly, these properties are also applied on the set operations. Like if two sets have the set operations, if they are equal to, if the order of the sets are to change or in the intersection. Let's consider commutative law. First is the commutative law. If two sets are given, A, set A and set B, A union B, if A union B is equal to B union A. Yes. Set operations on A union B is equal to B union A. Let's consider A is 1, 2, 3. B is 3, 4. Then A union B becomes 1, 2, 3, and 4. And B union A also 3, 4, 1, 2. A union B, the elements in A union B is same to B union A. Then we can satisfy that, or we can say that the set operations of union is commutative in nature. Similarly, set operations on intersection A intersection B is equal to B intersection A. Is it true? A intersection B common element is 3. For the B intersection A, common element is 3. Hence, we can say that A intersection B is equal to B intersection A. It means set operations of intersection of two sets is commutative. Then the associative. If there are 3 sets are given, A, B, and C. A union B union C is equal to A union B union C. If it is true, then we can say that the operations of union of sets is associative. Let's 5, 6. There are 3 sets A, B, C. A is 1, 2, 3. B is 3, 4. C is 5, 3. 5, 6. Then A union B. Bring the principle. A union B is 1, 2, 3, 4. And union C 1, 2, 3, 4, 5, 6. And here 1, 2, 3, 4, 5, 6. We can say that the set of operations of union of sets is associative in nature. And similarly, the set operations of intersection of sets is also associative. So from the above, we can conclude that the union of two sets is operation of union of two sets is commutative. Operation of intersection of two sets is also commutative. Operations of union of sets is also associative, and operations of intersection of sets is also associative. It means that operations of union, set operations of union and set operations of intersection are commutative as well as associative in nature. Next is the De Morgan's law. What De Morgan's law states? It states that the complement of union of two sets is the intersection of their complements. And the complements of intersection of two sets is the union of their complements. This is the De Morgan's law. It's named after mathematician De Morgan. Let's consider with the help of the example. And what are the law? Law states that this law states that complement of A union B is the A union B, or the complement of union of two sets is the intersection of their elements, element A, element B, and intersection of complements of two sets is equal to the union of their complements. This is the De Morgan's law. This is the De Morgan's law. Let's consider it with the help of the complement. Complement is the reverse of the universal. It means if there is a set, that is the set of odd integers. The complement of that is the element which are not odd. U is a set. Let U is a set 1, 2, 3, 4, 5, and 6. A's value is 2, 3. B is equal to 3, 4, 5. Now, what is A union B? A union B. From the set operations, union set operations, A union B is 2, 3, 4, 5. A union B, 3, 4, 5. So what is the complement of A union B? A union B complement states that the element which are not in this set, or element which exist in we can minus from the universal set. 2, 3, 4, 5, A union B. 1 and 6 is the intersects. Yeah, this or we can state that U minus A. It is the complement of A union B. 1, 6 is the intersection, or is the complement of A union B. Complement of A union B. Now, what is the complement of A? Complement of A, 1, 2, 3. 2, 3, and union is 1, 2, 3, 4, 5, 6. Then 1, 4, 5, 6. And complement of B is 3, 4, 5. 3, 4, 5. Then complement of B is 1, 2, 6. A complement intersection B complement is intersection is the common element 1 and 6. We reach on the conclusion with the help of this example that A union B complement is the complement of elements of A intersection of A and B. Similarly, it can be verified with the second A intersection B. Okay. What is the A intersection B? A intersection B. A is 2, 3, 3, 4, 5. The common element is 3. What is the complement? A intersection B. Complement is 1, 2, 4, 5, 6. A intersection 1, 4, 5, 6. B A complement is 1, 4, 5, 6. B complement is 1, 2, 6. Then A complement union B complement. A complement union B complement is 1, 2, 4, 5, and 6. Hence, we had proved or verified the second also, that is the A intersection complement of A intersection B is equal to the complement of union of A and complement of B. This is the De Morgan's law. I hope you understand this chapter very well, that is the operations on sets and properties on operations of sets. In the next section, we will solve all of the examples of chapter 1. Till then, thank you. Keep watching our channel HomeLearns. And please also ask if you have any problem by commenting on our videos. Thank you. Thank you very much.